Hello everyone, welcome back. In this lecture, we are going to start talking about the effect of environmental effects on the performance of the bituminous pavement, right. So far we were only talking about the modulus, the measurement of modulus for different layers. So now we are going to see how the environmental effects affect those modulus parameters, to what degree these modulus parameters vary depending upon the environmental effects, because ultimately if there is a variation in modulus for a given stress condition, the strain is going to vary. If we take a typical pavement, right, the load that we experience from the vehicle is going to remain a constant, right. Let us say that it is a typical loading scenario we experience in a pavement. So now the amount of strain that we get, right, the amount of strain that we, let me use the conventional denotation, the amount of strain that we get for a given stress is going to ultimately depend on the modulus value. So if my modulus value decreases significantly because of these environmental effects, then I am going to have a larger strain that I will experience in my pavement, right. So as the strain keeps increasing, and if the strain is not able to recover back quickly, we are going to have large amount of permanent deformation, right. So in this aspect, it is important to quantify the effect of environmental factors on this modulus value. How sensitive is this modulus value depending on the environmental condition. Again, depending upon the type of layer, for a granular layer, the climatic parameter that changes the modulus is different. For a bituminous layer, the climatic parameter that influences the modulus is different. So we have to identify what is the climatic parameter that influences this modulus value and what is the sensitivity of this modulus to these climatic parameters. So that is what we are going to discuss in the next 2 or 3 lectures. Right, let us get started. This is the outline. We are going to first talk about environmental factors. Again, we are not going to go into the depth of these environmental factors, just identify what are these environmental factors, and then we start quantifying what is the influence of these environmental factors on the moisture content. So we are going to talk about soil water characteristic curve, which is used to quantify the strength and permeability aspects of the soil. Then we are going to see what is the effect of moisture on the modulus parameter. Similarly, we are going to take another parameter, temperature. Though there are a lot of environmental parameters that will be influencing the performance of the pavement, we will be seeing that moisture and temperature are the 2 main parameters that we will be concerned about from the design perspective, at least from the influence on the modulus value. So we will talk about temperature, we will talk about pavement temperature, right. So how it is influencing the pavement temperature and what will be the effect on modulus. Finally, we will summarize. So this is the outline of this presentation, that wherein we will be talking about the influence of environmental factors, identifying them and quantifying the sensitivity of modulus. To start with, so this is a very generic representation of the effect of environmental factors on the pavement. So let us start identifying what are the parameters. The first one is solar radiation, right. The solar radiation is amount of radiation that we receive from directly from the sun, right. So we know that during summer the solar radiation will be high, and during winter the solar radiation will be less, and so on. So this solar radiation is the first and foremost parameter which influences the temperature conditions of your pavement. The next parameter is wind speed. So this wind speed influences the degree of heat transfer that happens between atmosphere and pavement. So we have that defined using a convection and evaporation process, right. So the convection process, once the solar radiation falls on the pavement, the surface of the pavement is heated to a certain degree, the temperature rises. Now the temperature, air temperature might be slightly lesser. So now there is a convection which happens between the atmospheric air and the surface of the pavement, and we also have evaporation that is happening between these 2 states, right. One is the pavement and the other one is the atmospheric air. So wind is the second parameter. It does not have any separate influence on its own, but it is going to govern the influence of other parameters on the pavement. The third one is we have atmospheric long wave radiation which falls on the pavement, right. So, it is not a solar radiation which comes from the sun, these are called as long wave radiations. Now, these radiations will fall on the surface of the pavement, some amount of these radiations will be absorbed by the pavement and some amount of radiations will be given back, which is called as the back radiation, right. So, this back radiation is what is scattered from the pavement and it is going back into the atmosphere. So, this is also another source of heat to the pavement surface. Apart from this, we also have precipitation. Precipitation is nothing but the rainfall, right. So, we have rainfall which occurs as a natural phenomena. So, because of this rainfall, the rainwater falls on surface of the pavement. So, this rainwater is going to influence the temperature of the pavement surface. So, one is the effect of rainfall on the temperature conditions of the pavement and the other one is the effect of rainfall on the moisture content in the pavement, right. So, because of this precipitation, water is going to fall on the pavement and rain on the sides. We will see shortly how this moisture is going to enter into this pavement system, right. So, this is, let me call this as the fourth parameter, right. So, one is solar radiation, wind speed, atmospheric long wave radiation and back radiation put together, and one more is precipitation. There are also other parameters. One we can say that as the cloud cover. Let us say there is a given amount of solar radiation. So, how much of this solar radiation, what percentage of this solar radiation reaches the pavement surface. So, that again is influenced by the cloud cover. If we have a higher cloud cover, this proportion is going to be less, right. So, cloud cover is another parameter. Similarly, we can also use another parameter which is sunshine instead of using the solar radiation parameter. This sunshine also says what is the percentage of sunshine that we experience on a given day. That is an indirect way of quantifying the effect of cloud cover. So, like this there are many parameters which we will be using and quantifying the effect of environment. Right. So, now there are three processes that happen in a pavement. Again, there are many processes that happen. We are interested in identifying the effect of three processes. The first one is convection, second one is evaporation and the third one is conduction. Convection is nothing but, okay. So, the heat transfer from atmosphere to pavement, right. So, this heat transfer from atmosphere to pavement depends on convection and radiation, right. We said there are this back wave radiation and atmospheric long wave radiation. So, these radiation effects are going to influence the heat transfer from atmosphere to pavement and back from pavement to atmosphere. So, we have convection and we have radiation, and there is also heat transfer between layers in a pavement. So, from the atmosphere, the amount of heat that falls onto the surface of my pavement, right, and how much of heat is actually reflected back and it is transferred from pavement to air is through convection and radiation. Whereas, once I have a given temperature on the surface of the pavement, what is the temperature gradient that I observe? What is the temperature gradient that I observe along the depth of the pavement? So, that is governed by this conduction phenomena, which mostly depends on the thermal conductivity properties of the individual layers. Right. So, these are the three phenomena. In addition, we have evaporation. So, once we have water on the surface and if there is some amount of heat that the ambience is experiencing, so there will be evaporation because of the heat conditions, right. So, convection, radiation is for heat transfer and heat transfer between layers is through conduction. We also have evaporation, which is mostly for the moisture aspect in the pavement. So, these are the factors which govern the influence of, or which help to quantify the influence of environmental factors onto the pavement system. This is moisture. We can now see how moisture influences the pavement system. What are the sources of moisture in a given pavement? Now, this is our pavement system, we can see here, right. There are two sources of water. One is from precipitation. One is from precipitation or rainfall, the other is from the groundwater table. Okay. So, this precipitation moisture content will enter into the pavement either through the discontinuities that are seen in the surface. Let us say that we have cracks on the surface of the pavement. So, this crack is not only acting as a initiation point for the damage, but it is also paving way as an entry point of moisture into the pavement system. So, this rainwater will enter into these cracks and then enter into the bottom layers. We have seen earlier even in one of our previous lectures we have discussed that among the many roles played by the surface course, one of the major function is to provide an impermeable surface, right. So, if it is a dense graded mix, it is going to provide an impermeable surface, and if it is an open graded mix, it is going to quickly drain water from the bituminous layers into the side drains, right. So, the discontinuities present, if any, it is going to act as a point of entry of moisture into the pavement system. Then the water will also enter the shoulders on the side, right. So, these shoulders also should be having some drainage considerations. Let us say that apart from the edge of the pavement, we have the soil layer which is present here. So, water which enters into this soil layer will also enter laterally into the pavement system. So, this is another point of entry of moisture into the pavement system. Let us say we have a high ground nearby, this is a pavement, we have a high ground nearby. So, there is also going to be seepage from a nearby high ground. So, this is another source of moisture entry. So, one is vertical entry and another one is the lateral entry. So, this is for the rainwater or the because of the precipitation. The next aspect is water table, right. So, there is water table at different depths depending upon the location. Information about water table is commonly available, otherwise this central groundwater board, I am not exactly sure, but there is something similar to this, a central groundwater board which prepares these maps which indicate groundwater table at different locations. So, from these kind of sources also we will be able to get information on the water table, right. So, we have water table. Because of this water table, there is capillary action. Depending upon the depth of water table, the capillary action may be relevant or may not be relevant. So, this groundwater table may also rise or lower down depending upon the seasonal variations in a given year. So, during rainy season there is a rise in the groundwater table, and during the dry spell there is a reduction. Again, how much it reduces and how much it falls is again governed by the precipitation factor. So, these are the effects of moisture onto the pavement. Now, what is the among these things we are going to focus on two parameters which are moisture and temperature, right. But is moisture going to affect all the layers in a pavement uniformly? So, we said that we have different layers in a pavement. We have the subgrade, subbase, base, binder and surface course. So, we said these three layers are granular, and for a typical bituminous pavement these two layers are bituminous layers. Now, is moisture going to affect all the layers in a pavement? What kind of influence it has on these two kind of materials? In a granular layer, it is directly going to influence the subgrade and granular layers in terms of the water content of the soil. So, we will be seeing subsequently, and we have also seen in the experimental procedure that the moisture content plays an important role in determining the strength aspects of the granular layers. So, obviously, once the moisture content increases, the strength is going to reduce, right. So, it has a direct influence on the granular layers. So, this is one aspect. There are many other aspects also. One is like it also affects the state of stress that the material undergoes under higher moisture content compared to a dry state. Similarly, it will also influence the freeze and thaw effects in soil. We will be discussing about all these aspects shortly. We can't say that moisture has no effect on bituminous layers also. It does have a certain degree of influence on the bituminous layers. What kind of influence? So once moisture enters into the pavement, let us say this is my surface irregularity, and so water enters here, this is my surface course, right. Because of the interconnected air voids, it might reach the binder course or it may not reach the binder course. So once water is present inside the bituminous layer, there is a higher degree of higher possibility for stripping to happen. So what do we mean by stripping here? It is removal of binder film from aggregates. So we know that bitumen is the binder which is holding together all the aggregates together in a bituminous mix. So once water comes into contact with the bituminous mix, it will slowly start ripping away this binder film from the aggregates. So now we will end up having loose aggregates. So that is why whenever you see a pavement with some cracks on the surface, slowly what will happen is the crack will start expanding. Once particles come out from there, there is more water that is retained on these cracks. It forms kind of a pothole. So this moisture can enter into the layer. It will rip the binder film from the surrounding aggregates, and that is why when we see an initial crack here, it will grow eventually into a large pothole. Right. So this stripping effect is a major concern for moisture, but is it going to affect my design? Is it going to affect my modulus? Not much of an influence on the modulus. Right. So this moisture content has a direct influence on the resilient modulus of the okay, I will use the terminology that we have used. It has a direct influence on the resilient modulus of all the granular layers. It is subgrade, subbase and base layers, but it does not have any significant influence on the modulus of bituminous layer as such. So if you ask me, will we be seeing any change in modulus because of this stripping effect? Not actually, right. So this is only going to influence the distress, but it has very less, it causes a lot of other effects because of which the modulus may reduce, but directly it is not going to influence the modulus. The next is the effect of temperature, right. This temperature is nothing but because of all these radiations, we have a particular temperature on the surface, and there is going to be a temperature gradient along the depth. Again, how it varies I will show you, because it is not simple to draw a line like this. There are a lot of variabilities that we will see in the temperature gradient along the depth of the pavement. So now this temperature is going to have a significant effect on the bituminous layers. We have seen earlier, for testing of bituminous materials, whether it is the resilient modulus or the dynamic modulus test, maintaining a precise test temperature is very, very important, right. So if there is a small change, if you see most of the test procedures will say 25 plus or minus 0.1 or maximum of 0.1 degree variation will be allowed for all the tests on bitumen. This is because temperature has a significant effect on the modulus parameters. Now, so this has a direct effect on, it could be resilient modulus. For bituminous mixtures, we typically use a parameter called E star, which is to indicate the dynamic modulus. So it has a direct effect on the resilient modulus and dynamic modulus of bituminous mixtures. Is it going to affect the soil layers? Not from the modulus perspective, but yes, it is also going to have some kind of influence on the soil layers. Yeah, I would not say that no effect on modulus, because there is water which is, let us say this is a soil system, right. There are voids which are present in the soil system. So water is now may be present in this voids. Depending upon the degree of saturation, there might be some amount of water which is present inside these voids. So once the air temperature reduces below a certain value, right, let us say that it goes to sub-zero temperatures. So once air temperature goes sub-zero, the water which is present in these voids is going to freeze, right. So because of this freezing condition, we are going to have ice formation in these voids, and the modulus of the layer is going to increase substantially. So that is one influence of temperature on the granular layers. So we can say that temperature actually influences both the bituminous layer and the granular layer, but in different ways. Shortly I will show you for increase when there is ice formation in the, yeah, I think it is in the next slide. Okay, so 2 slides down I will show you when there is moisture increase in the pavement, there is about 20 to 60 times increase in resilient modulus, right. So temperature has an influence on both the modulus of bituminous layer and the modulus of granular layer when there is ice formation. If there is no ice formation, let us say in a country like India where or let us say that except for some portions of the northern part where temperatures fall below 0, for most of the other parts of the country we rarely experience sub-zero temperatures, and this kind of an ice formation would be a rare phenomena. So in that scenario we can ignore the influence of temperature on the modulus of granular layers, right. So this is with regard to the influence of both these parameters on the pavement. Now let us start talking about moisture in specific, right. How moisture influences the modulus value, how is it taken into consideration, and what is the degree of influence on the modulus parameters. So in a generic tone, moisture evolution in a pavement system throughout the year, right. You know that over a given calendar year, depending upon the seasonal aspect that that particular location is going to experience, there will be fluctuations in moisture content. So there will be temporal variations, that is variation with time because of these moisture effects. So the variation in a year is a result of complicated interaction of several factors which contribute to moisture intake and removal. So if I have a pavement system, we said there are 3 factors which are going to cause moisture influence. One is precipitation, one is lateral drainage, one is this capillary action, right. Similarly, there are phenomena through which water will be removed from the pavement system also. So let us look into what are these factors. There are generally studies define that there are 4 sources that contribute to moisture intake in a pavement structure. What are these 4 factors? One is infiltration of precipitation water, like we said earlier, the rain water which is going to enter into a pavement system because of irregularities in your surface. The second one is lateral moisture transfer from a nearby shoulder or an earthen surface, or there could be a high land and because of the seepage. Third one is capillary rise because from the groundwater level, and the fourth one is frost and thaw action. Right, these are the 4 sources that contribute to moisture. So once the water freezes, when it is thawing, it is going to release water. So that is what is through this frost and thaw action. And there are 2 main factors which contribute to moisture extraction from the pavement. What phenomena removes water from your pavement system? One is moisture drainage, right. Like we have a capillary action, because of permeability, water is going to also drain off from your pavement system. That is one aspect of removal. The other aspect is moisture evaporation. So we have seen in the earlier slides also, evaporation is one phenomena which is interaction of the pavement system with the environment. So because of this evaporation also, there would be moisture removal from the pavement system. So this is nicely indicated in a thesis by Salar. You can see here this is a typical pavement system. So these are the 4 factors which lead to moisture increase in a system. The infiltration part, the lateral water transfer, especially when you have an embankment or a higher area nearby. Even otherwise, if you do not have anything, there would be soil nearby, and because of the soil there would be lateral entry of moisture, and the granular layers might be more affected because of this lateral water transfer. And then there is this frost action also, and capillary rise from this water. This is the water table level. From this water table level, there would be capillary action into the bottommost layers of the pavement. And what are the phenomena through which water is drained? One is evaporation and the other one is drainage from the pavement. At freezing temperatures, previously I was talking to you about the influence of temperature on granular layer. So as temperature reduces, as it goes below sub-zero, water in the soil freezes, right. So, there would be a natural moisture content which is present in the soil, and the water would be present inside the voids, right. So, whatever is the water, maybe the saturation content is 20% or it could be 30%, whatever be the natural moisture content, this moisture content will freeze in the soil, and because of in the freezed condition, the resilient modulus can rise up from 20 to 120 times higher than the value of the modulus before freezing. There is a substantial increase in modulus because of this freezing effect. However, if you have unbound materials which are not affected by, unbound materials are not affected by temperature until ice forms below 0 degree Celsius. So, that is why I said when we have locations which experience sub-zero temperatures, we have to consider the effect of temperature on resilient modulus of the granular layers. So, until we experience sub-zero temperature, it is not going to be a major factor. This freezing process is accompanied by the formation of ice lenses which induce zone of reduced strength. I will show you what this ice lens formation is. So, there is formation of ice lens which induces zone of reduced strength in the pavement when thawing occurs. Let us see what this ice formation is. So, this is a typical pavement system, right. Let us say that air temperature is below the freezing temperature. So, this is a pavement surface, again not a typical pavement cross section used in India. I have taken it from this particular reference, and for them they have a surfacing, a base and a subgrade. This is the composition of the pavement. So, you can see here as temperature reduces, we have these voids which were filled with water. Not necessary that all the voids should be completely saturated with water. Depending upon the degree of saturation, a certain degree of voids will be filled with water. So, this voids which are filled with water freeze when the air temperature falls below sub-zero, right. And also there is subgrade which is also frozen, right. The water which is present in the voids in subgrade is also frozen. Now, there is below a particular point there is an unfrozen subgrade, right. So, this subgrade will still allow capillary water to rise in the pavement because this has not yet reached 0 degrees, right. It has not yet reached the freezing temperature, the temperature here is slightly higher. Now, this will allow capillary action. Now, there will be a plane of freezing, right. If you look at this, you can see here there are ice crystals which are initially formed here. So, water in large void space. So, when you have a small void space, there is only small amount of water, the effect is insignificant. You can see like they will remain as isolated pockets, right. When you have a large void space and it freezes into ice crystals along a plane of freezing temperature. So, what will happen is eventually there will be a plane that will be formed wherein more number of air voids are present, something like this. Okay. So, these ice crystals will freeze. So, ice crystals will attract water from adjacent voids. So, once you have ice crystal, it will tend to attract water from the adjacent voids which are present. So, this will also freeze on contact and form larger crystals. So, a small ice crystal which was present initially is attracting water from the adjacent area and it begins to increase in size, right. So, now this ice formation will attract more water from this water table because of capillary action and it will increase. This water is able to move because below this ice lens there is an unfrozen subgrade, right. So, your entire subgrade does not freeze. So, once there is this ice lens formation, below that many studies have shown that the temperature is slightly warm and it is an unfrozen subgrade. So, this will allow movement of more water towards this ice lens and once it reaches here it will start freezing and the ice lens will grow in size. So, crystals continue to grow and join forming ice lens. So, there is a vertical pressure exerted by ice lens and it tries to heave the surface, right, it tries to push the surface upwards. Okay. So, this is the effect, freezing effect. So, now once this freezing effect is like over and the temperature begins to increase, we will experience the thawing effect. So, during this thawing effect what will happen is this portion which was like completely filled with ice previously will now thaw right, the water will all move out, it will be like completely filled with water. This will act as a point of reduced strength. So that is what it says, it acts as a zone of reduced strength when thawing occurs. So this is one aspect. Then the bound materials are not directly affected by moisture, maybe excessive moisture will only lead to stripping in asphalt mixtures. So this is the influence of moisture on the pavement. Now let us see what happens during thawing. So let us again consider a similar kind of pavement system. So wherein you have a surface course, you have a granular layer, and then you have a subgrade, right. So this is the depth up to which there is a thawing effect that we will observe. Now the gravel below the asphalt, this is the asphalt layer, the gravel below the asphalt will contain high percentage of fines. Again this is for another composition, another kind of material, will have high percentage of fines, and the water will become, and this will become water saturated during the early thaw, because when there is up to this depth there is a thawing effect. So now because of this thawing there is more water that is released, and so this will become, this gravel layer will become completely saturated with water. Now when a wheel passes this particular point, at for a given instance, for a moment or for a fraction of a second, because this gravel is completely saturated, the entire load is passed on to water, right. The load is transferred during the first tenth of a second to water, because gravel is completely saturated. Now, so once the load is transferred to water, the high pore water pressure, the pore water pressure increases and makes this gravel unstable, right. There is pore water pressure, because of this pore water pressure it is trying to push the soil upwards, and we have restricted drainage here, there is no place that it can move, and the drainage is also very slow because this layer is kind of more permeable. So since drainage is restricted, the pore water pressure creates an upward pressure towards asphalt. So since the drainage is constrained, it tries to push this asphalt layer upwards, right. So when this force is significant, it starts cracking, it starts to form cracks on the surface. Ultimately, depending upon the magnitude of this pressure, pieces of asphalt may also be pushed out, right. So the edges of impact crater, so these edges may break, and then the gravel will just disappear out of it, okay. It might also be pushed sideways, which cause rutting. So this is the freeze and thaw effect which is observed in a pavement, right. So we should keep this in mind. Again in India, like I said, sparing a very few locations, most of the other locations do not experience this freeze and thaw effect. That is why it hardly finds place in any of our codal provisions also, and we will also not be looking into the detailed aspect of this freeze and thaw effect. So this is a typical curve which shows the moisture variation. Again this is for a particular location where the variation is given over different months. So January, February, March to December. We can see how the water content varies as a function of the duration. For sand, silt and clay, we can see here that the moisture content fluctuation is high in the case of sand, relatively less in the case of silt, and low in the case of clay. Again this is for a specific location, this might tend to vary. Again it is only the type of soil only is given, the gradation and all the other aspects of the soil is not mentioned here, it is subject to vary, but this is a typical trend that we will see. If you have a clay, it has very less change in moisture content, again for this location. If you have sands, there is relatively higher variation in moisture content. Next we will be looking into the soil water characteristic curve. This is an important parameter which is used in calculation of modulus for granular layers. I will stop this lecture here. In the next part we will talk about soil water characteristic curve and its effect on modulus.